Okay, this is my 60 plate dry cell. It is made out of 8x8 316L grade stainless steel. The way I have wired it is to run on both 120 and on 13.5 volts, or in a car. So the way it's working on 120 volts right now is it's going from the panel box through the wire into this bridge rectifier. This is a 90 amp bridge rectifier. It takes the AC current and converts it into DC current, which is what it needs to be in order for electrolysis to occur. So it's taking 120 volts right now, converting it to DC, and the leads, the power leads right now, are just on either end of the cell. So there's a power lead on this end, a power lead on this end. It doesn't really matter which power lead would be positive or negative since they're just on the ends. But so that's how it's wired right now. And I'm measuring the current after the bridge rectifier. So a straight DC current or amperage into the cell right now, and it is hitting about 6.1, 6.2 amps. Now, I'll go ahead and show the voltage. If you'd hold that. So I'll change it over to voltage, and I'm going to measure the AC voltage. So you want to look at that screen. So we go from the AC current right here. It is measuring 121 volts even, pretty much. Right there, 121. So 121 volts, and then I'll put it back to the amps for the DC right here after the bridge rectifier. So I'm measuring the amperage, so it measures what actually goes to the cell, because the bridge rectifier takes a little power to convert it, and I'm going to test the cell itself and not compare the AC current. So it's drawing 6.3 amps now, 6.2, 6.3. The way I'm measuring this now is with this bottle right here. I've measured 1 liter of space between the bottom mark and the top mark. I began with filling the bottle to that bottom mark, and then I took a measuring cup and I put in 2 500 milliliters of water, which is going to be equal to 1 liter. And I filled it from that line, and then after I added that liter, I made another line. I went ahead and I drilled holes in the bottom of the bottle, so that way now it's completely full with water. So whenever I start pumping the hydrogen in, whenever I connect the hose, I will time it whenever it pushes the water out through the bottom. And whenever it hits this line, I'll start the timer. And whenever it hits the next line, I stop the timer. That means that it would have filled between there and there with hydrogen, which is 1 liter per minute, or 1 liter. And then I'll time how long it takes. Okay, so I'm about to do that. Hold it right about here. Okay, and I'm going to use the stopwatch right here to do so. So, I got my line in right here, line to the bottle right there. So we're already at 6.5 amps, because as the water warms, as the cell runs, the water gets slightly warmer. And while it's warming, for reasons I haven't figured out yet, it draws more current, and if it draws more current, it produces more hydrogen. So right around 6.6 seems to be stable. Right here's the stopwatch, and down there, whenever I pick it up, just measure the stopwatch and that. So I go ahead, I connect it. It'll take a second for the hydrogen to get flowing, and then we'll time it. So I've made the connection, and then the hydrogen's flowing. It reaches the mark, I start it. And down there, you want to make sure you can see all the bottom line and the stopwatch at the same time. So it reaches the bottom mark, I stop it. It took 13.3 seconds. So now we're going to go ahead and do the math. Sorry about that. I go ahead and do the math. 13.3 seconds. So we have 13.3 seconds, and we'll write that down. So we have okay, sorry about that. So we pull up the calculator, and it was 13.3 seconds. So we see how much that is of a minute. So we do 13.3 divided by 60. That's 0.2216667. So that's the percentage out of a minute. So we do that. We do 1 minute divided by 0.2216667 equals 4.51 liters per minute. And so we have 121 volts times the 6.6 amps, and then divided by how many liters per minute that is. So 121 volts times 6.6 amps, that's 798 watts, and then we want to know how many watts per liter, so we divide it by 0.51 equals 177 watts per liter. Now that number varies slightly with each test, depending on how much it's producing. The cell seems to get more efficient the more hydrogen we produce. But 177 watts per liter is pretty good number right there. And that's my video for now. Thank you.